Welcome to my YouTube channel Raise a Cat, and today we will see what is the concept of time constant. Okay, so in the electrostatics, okay, RC circuit, we will see what is the concept of time constant. Okay, so suppose that how we will see the time constant. Okay, so or how it is denoted, time constant. So time constant is denoted by tau. Okay, so this, in the electrostatics, this is denoted by tau, and suppose that this is an RC circuit. Okay, RC circuit. Okay, so what is an RC circuit? RC circuit is there in which there is a capacitance. Okay, and there is also a resistance. Okay, and this is a battery. Okay, so suppose that its capacitance is C. Okay, and its resistance is R. Okay, and its this voltage is V. So how we will write the equation? Minus V plus Q by C. Okay, because Q is equal to C into V, so V is equal to Q by C. Okay, so this is having plus, this is having minus, so minus V plus Q by C plus IR is equal to 0. So this is the equation of this RC circuit. Minus V plus Q by C plus IR is equal to 0. Okay, so like this we will write the equation. Suppose that the current in this is I. Okay, so if we solve this equation, we will see that the Q will be equal to Q naught e to the power of minus T by R into C. Okay, this will be the equation of this RC circuit. Q is equal to Q naught e to the power of minus of T by RC. Okay, so and how the graph will be there? E to the power of minus x kind of graph. Okay, so like this it will be there. RC discharging. Okay, so at time t is equal to 0, Q will be equal to Q naught. Okay, at time t is equal to 0, suppose that it is fully charged, the capacitor is fully charged, and the charge was Q naught. As the time passes and time t is equal to infinity, the charge will tend to 0, or it will be fully discharged. Okay, so at time t is equal to 0, the charge was Q naught, and at time t is equal to infinity, the charge is 0 in this. Okay, so the like this the graph will be there, Q versus T. Okay, and here the Q is equal to Q naught. Okay, Q is equal to Q naught e to the power of minus T by RC. This equation is very important in the RC circuit. Okay, and this R into C is the time constant. Okay, so this denotes that how this charge will degrade. Okay, so this is the time when the charge will be 63% of the initial value. Okay, so what is the half life? Half life is when it is degrading 50%. Okay, and when it is 63% degrading, that will be the one time constant. One time constant. It is 63%. Okay, so in one time constant it will be degraded 63%. Okay, so 63% will be degraded, so what will be remaining? 37% will be remaining. Okay, so 0.37. Okay, or 1 by E. Okay, if we calculate this value, we will get 1 by E. 1 by E will be remaining. So what will be what was the function of Q? Q is equal to Q naught e to the power of minus T by RC. Q is 1 upon E naught. 63% is 63.2% is degraded. 0.632. Okay, so in percentage if we calculate, we what will get 63.2%. so 63.2% degraded, so what is remaining? 37% approx. Okay, so which is 1 by E. Q naught is equal to Q naught e to the power of minus T by RC. Okay, Q naught to Q naught cancel, 1 by E is equals to E to the power of minus T by RC. ln of 1 by E is equals to E to the power minus T by RC. Okay. So this is equal to ln of 1 by E minus 1 is equals to minus of T by RC. So what will we get? T is equals to R into C. Okay. So like this we will calculate. We get the time constant is equals to R into C. So what was the time? What was the remaining concentration of the charge was 37%, and what was gone 63.2%. Okay. So if we calculate also, if we want to solve and prove, we can also prove that when the concentration remaining is 37% and 63% is gone, what is the time which is there? Time is equal to R into C, and it is equal to a time constant. Okay. So like this we can also see. Okay. So this is the figure of the RC circuit. Okay. In the LR circuit also we can do LR circuit, in which there is a inductance L into R. Okay. So like in that case we can also prove this. Okay. Thank you.